on this computer. Okay, so I'm recording. Okay, questions?
I have a question about the worksheet for this week.
There was a mistake in question 1 and also a few typos.
Okay, yeah, I know you did some revisions.
Yes. So now
Maybe that's what tripped me up.
Now the file is correct.
Okay.
Did you already do number 2 from the homework?
Let me see. No, I did not. So we only looked at how we derive the formula in question 3.
Can you do number 2?
Sure.
Thank you.
Okay. So number 2 is the most confusing one. I mean, I had so many questions from you, but actually it was very simple. So there are many separating and pooling equilibria in this question, and I was only asking you to find just one. So in this question, we have, okay, let's see. Okay, we have a company. There are 2 types of productivity worker. High productivity workers produces $60 worth of good, and low productivity workers produces $40 worth of good per hour. So the company knows that 50% of the workers are high productivity and the remaining 50% is low productivity. So the company does not know who is high productivity and who is low productivity. So workers can use master's degree as a signal to tell the employer, the firm, that they are high productivity. So if they get a master, of course, high productivity workers, the cost is lower. So it is as if they are losing a $10 wage increase. And for low type, it's costlier. The cost is 30. Okay, what else? What else do I know? Well, the firm cannot observe the type, but it can observe whether the person has a master's degree or not. So we are going to find a pooling equilibrium. Okay, what is a pooling equilibrium? A pooling equilibrium is you are going to offer a wage rate, and all types will choose this wage rate. Okay, so in other words, when you see the workers' preferences, you won't be able to tell who is high type, who is low type. Okay, so how can I do this? Well, remember that 50% of the workers are high type and 50% of the workers are low type. So I can create a contract including 3 types of wage. Okay, I'm gonna offer a WH. I'm gonna offer a WL, but I will also offer kind of a third wage, an average something between WL and W. Can you guys hear me? Can you hear me?
Yeah, I can hear you.
I mean, I'm asking because my dog is barking. I'm trying to figure out if it's too loud.
Yeah, you're good.
We can still hear you.
Can you hear me? Okay. Because if you cannot, I'm gonna lock the door somewhere. Okay. Okay, so the third one is something between WH and WL. Okay, so here you can choose any wage you want, we are gonna check whether the people will choose this wage or these two wages. So here it says 50% of the people are high type and 50% of the people is low type. I will simply take the average of the two. Okay, so let's say that the third wage is the average of WH and WL.
Professor, I had a quick question.
Give me a second, I'm gonna lock my dog. Tospik! You know what's gonna happen now? You know what's gonna happen? No more. Okay, question?
Yes, I was wondering, do you take the average in this example because it's 50% each? The probability is 50% for high, 50% for low? Or is it just the average because it's pooling?
Well, here I wanted to try the average, but like other rates between WH and W8 may work too. So here the reason I chose this is because I want my company like ex ante to have exactly the same cost. So instead of paying WH to, I don't know, 10 people and WL to 10 people, the company is offering the average to 20 people.
So like, would you offer the average if like, for example, like if there was 70% were L and 30% were H, would you still
I
offer
would
the
get
average?
70% of WH and 30% of WL.
Okay, thank you.
Yeah, but as I told you, if you take 50-50, you may still find a pooling equilibrium. Here, the reason I did this is because I don't want my firm to be worse off. I want my firm's, how do you say, costs to be exactly the same. Okay, so now I'm offering WH plus WL divided by 2 to everybody. So here, there are three types of wages. I'm offering an average wage, a high wage, and a low wage, okay? But of course, in order to get the high wage, the workers need to prove me that they are high type. So in other words, I'm going to offer WH to people who has a master's degree, and I'm offering WL to people who has no master's degree, okay? And I'm offering this to everybody. Now, why I want a pooling equilibrium, right? Which means that I want people to choose this. Because if people get a master's degree and choose this, I know that they are high type. If people don't get a master's degree and choose this, then I know that they are low type. So this will be a separating equilibrium. If everybody chooses the same wage, then there is no way I can tell whether the person is high type or low type. Does this make sense?
I guess my question is, I know we were given the values of $60 and $40. Are those not the wages? Like we can't plug those into the WH and WL to find the pooling equilibrium?
No, you cannot. 60 and 40 are the, how do you say, are the productivity of the worker. So the worker is creating a product worth of $60.
Okay.
So you don't know whether the company is paying the worker exactly its productivity.
Okay. Okay.
So I know that if the company would never pay anything above $60 to high worker, or anything above $40 to low type. Okay. All right. So Remember, I'm trying to make everybody choose this contract. So let's start with the high type. So if you're a high type worker, you want, I want you to choose this. So if you choose this, you are gonna have this wage. In this case, are you gonna get a master's degree or not? Should you get a master's degree?
No.
No, because it doesn't matter whether you get a master's degree or not, everybody is offered this wage. If you choose to get master's degree, you will have a -10 here. So you never want to have a master's degree, okay? So I want this payoff from the pooling wage to be greater or equal, or, I mean, it doesn't matter at this point, than me as a high type choosing to get a master's degree and is offered WH. So the right-hand side is the payoff when H type gets a master's degree. Hence, the firm knows that he is H type, so he is offered WH. Does this make sense? Okay. So this is for high type. For low type, I have a similar constraint. I want the low type to be better off by choosing the pooling wage than choosing the wage that is offered to him. I know that this guy is going to choose to have no masters and will be offered WL. So I want these two things to hold.
Why isn't it WL minus the cost of the master's degree? Because shouldn't it be like their best option? Or is
I
it?
mean, think about this. If you are offered WL, would you want to get a master's degree?
But doesn't it increase your wage?
Well, you mean WH minus 30.
Yeah. I think I just assumed that your wage would go up if you got a master's degree.
Yeah. I mean, we can check that too, but only one of them is going to be binding. So wait for this now.
Okay.
So remember, I'm comparing a pooling equilibrium with a separating equilibrium. So I want high types in a separating equilibrium. I want high types to get a master's degree and low types not to get a master's degree. So the left-hand sides are pooling in the sense that everybody is choosing this and not getting a master's degree. So I cannot tell who is high type, who is low type. The right-hand sides are H type is choosing to get a master's degree. So I can now find out who is high type. And low types are not choosing to get a master's degree. So I can tell who is low type.
So you're comparing the separating equilibrium
With a pooling equilibrium. Yes.
Okay, so in the pooling equilibrium, okay, nobody would get.
Yes.
So that's why there's no minus for anything.
Yes.
We want it to be a separating equilibrium, so we want the low productivity worker not to get a master's, so we know that.
Yes, exactly.
Okay.
Exactly. All right. So, yes.
Is it safe to assume that this equation is from the eyes of the worker or the employer?
So here, the employer is looking from the eyes of the worker, but we are looking from the eyes of the employer.
Okay, so would that make sense as to why in the L type we're looking for WL and not W high minus 30, right?
Well, if you look from the perspective of the worker, I mean, these inequalities belong to the worker.
Yeah.
right? So the worker says, should I choose the pooling one or should I choose to get a master's degree and get WH? So this is from the worker's point of view. But us, like constructing this to choose WL and WH, we are the employer.
Okay.
Does this make any sense? So the employer thinks that the workers have these constraints and chooses WL and WH looking at these constraints.
Okay, yeah, that makes sense.
Okay, all right. So, okay, so let's rearrange these. Okay, so I'm gonna take the first one. So this will be, if I multiply both sides by 2, WH plus WL is greater or equal to 2WH minus 20. So I have W, the second one, again, I'm multiplying by 2 to WL. Okay, now, what am I gonna do? I'm taking this again. I'm simplifying, that's it. So I have WL plus 20 greater or equal to WH. And here I have WH greater than WL. Does this make sense? I have two inequalities. I can create a chain here. This is greater than WH, W is greater than WL. So I need to choose a WH, which is greater than WL, but less than WL, WL plus 20. So for instance, I mean, there are many, many possibilities. For instance, if you choose WL 10 and you choose WH anything between 10 and 30. So let's choose, I don't know, I can choose 25, for instance. Then which wage I'm gonna offer? WL is 10, WH is 25, and the common wage is simply 17.5, okay? In this case, everybody is going to choose this common wage and nobody is going to get a master's degree.
Can you move the paper up a bit?
Oh, okay, wait, I don't see it. Oh.
Thank you.
So I simply manipulated this, that's it. I have two inequalities. And remember, I was trying to find an interval for WH and WL.
So when you combine those two inequalities, you get what's in the right?
Yes, the right and the square.
I don't know if you did this before I joined, but could you go over number 1 on the practice exam?
Yeah.
Like the response, not the multiple choice.
Yeah. Let me finish this question. So this was the pooling equilibrium. Do you guys want to see the separating equilibrium as well?
I just had a quick question about the what you just finished.
Yes.
Why? So if the WH is 25, does that correspond to what the high workers would get if it were separated.
Yes.
So why would they choose to go into a pooling where they would get lower payoff, like a lower wage?
They don't get a lower payoff. If they choose WH, they need to get a master's degree, which will cost them $10.
It'd be 15. Yeah.
Yeah.
That makes sense.
And would you express that as just WH equals 25?
Yes. Okay, guys. If you don't have questions about the homework, I'm switching to the practice test. All right. Practice test, question 1. Edward, was that you asking question 1?
It was Reed.
Okay, read. So when did you download the file?
Yesterday.
Okay, because I made changes on it. There was a mistake. Wait. No, this was the worksheet. Okay. Okay, ignore me. Okay, so you said problem number 1, right?
Yeah.
Okay, so we have a game between a worker and an employer. And there's no firing, no quitting. The employer can pay a high wage, WH, or a low wage. The worker can work with a high or a low effort. So effort low, effort high, okay. And remember, this question is different than the question we just solved. In that question, the workers had a type. They were not choosing their types. So the worker was either low type or high type. Here, each worker is choosing whether to be low type or high type, okay? So that's different in that case. Okay. So high effort generates revenues WH, and low effort generates revenues YL. So assume that the worker like getting paid and dislikes expanding effort, of course, effort. And the payoff of the utility of the worker is W minus E. So the higher the wage is, the lower the effort is, I'm happier, okay? And the employer cares about the profit, which is Y minus the wage that he pays. So here I'm giving the values for pretty much everything, YH, YL, WH, WL, EH, EL is equal to 0, and we are gonna draw the payoff matrix. So now, if this is wage, right? So this is the firm, and this is the worker. So if the firm decides to give high wage, remember the first values will belong to the firm, okay? If the firm decides to give high wage and the worker decides to put low effort, then since the effort is low, the output is gonna be low, 4, and the company is paying a wage of 6, so 4 minus 6, the company is getting a payoff of -2. Questions? Okay, here with WLEL, WL is 2, the company is gonna get again low output, so 4 minus 2, this is 2. With high effort and high wage, WH is 6. Since the effort is high, output is gonna be high as well. 10 minus 6, this is 4. And if the company pays low wage with high effort, YH is going to be the output. 10 minus WL, which is 2. The company is going to get 8. Okay. Well, even without completing the table for worker, I can easily see that WL is a strictly dominant strategy for the firm. Anyway, so let's complete the table. If the firm pays WH and worker puts low effort, WH is 6, low effort is 0. So 6 minus 0, 6. With low wage, WL is 2, EL is 0, so this is 2. High wage is 6, high effort is 2, so 6 minus 2 is 4. Low wage, high effort, WL is 2, high effort is 2, so this is 0. Okay. Again, checking the workers' payoffs and strategies, I see that low effort strictly dominates high effort. Okay, so I have 2 strictly dominated strategies, WH and EH, which gives me a dominant strategy niche equilibrium at WL, EL. Okay. So the firm is going to pay a low wage and the worker is going to put low effort.
How come intuitively that is the Nash equilibrium?
Well, this is classic prisoner's dilemma. You can see that the firms have strictly dominant strategies. Why do you think that the firm is playing WL?
Because they pay less?
No, because they know that if they pay WH, then the worker is not going to choose EH. The worker is going to choose EL. And the firm is going to end up getting -2. Okay, I'm repeating again. You said that the firm pays WL because the wage is low, right?
Mm-hmm.
That's not the case. Well, yes, the wage is low, but the firm is getting 2. If the firm believed that the worker would play EH, then he would have played WH and get 4 instead of 2. Right? The reason why the firm is playing WL is because he knows that if he doesn't play WL, if he plays WH, the worker is going to play EL. And he's going to end up getting -2, not 2. So this is the classic intuition behind prisoner's dilemma. Why do you confess in prisoner's dilemma? Because you expect the other player to confess too. And you know that if you deny, the other person is going to confess. Does this make sense?
Yeah. Wouldn't they always just choose WL because the payoff is greater for both of them, since it's like the dominant one?
Yeah, I mean, this is, how do you say? This is more of a mechanic explanation. So the idea behind it is this. I mean, yes, but why WL is dominant? I mean, WL is dominant. Okay, how do I say this?
Isn't it just dominant because to get the number in the boxes, you're subtracting by the wage, so you want to subtract by the lower wage to keep the higher number?
Yeah. So this is, how do you say? This is an explanation using best responses. The explanation I gave you was using rationalizability. So what I said is the firm would never play WH because he knows that the worker is going to play EL. So he cannot rationalize WH. But what you said is correct too. Okay, let's see. This was part A, right? Now part B. I'm trying to make the good equilibrium, the good outcome in equilibrium. So I want to make sure that WH and EH is in equilibrium. How can I do this? So the first thing we will try is we are gonna show that from the worker's point of view, the worker should cooperate by choosing high effort if he is faced with a grim trigger strategy. So in other words, here what we will do is the worker is going to play the following strategy. I start with high wage. As long as I see that you are putting high effort, I'm gonna keep paying you high H. As long as I'm gonna choose WH. Otherwise, I'm gonna switch to paying you WL. Okay, and I know that the interest rate is 0.25. The discount rate, you guys remember that the discount factor is equal to 1 divided by 1 plus R. So here I have 1 divided by 1.25, which is 0.8. So I'm going to discount future payoffs by 0.8. Okay, so I'm trying to show that under this strategy of the worker, the best response, sorry, this is not worker, this is the firm. So the best response of the worker is simply to choose WH all the time. Okay, so if you guys need to correct me to choose high effort all the time. So if the worker chooses high effort all the time, and remember the firm started paying WH, is gonna get 4, right? So each period the firm, the worker is gonna get 4. So 4 plus, next period is 4 too, but I'm discounting it by delta. And 2 period from now, I'm discounting twice. 3 period from now, I'm discounting it 3 times. So I have this, which is 4 into a parentheses of 1 plus delta squared, which is 4 divided by 1 minus delta. Okay, and remember, delta is 0.8. So 4 divided by 0.2.
Why is it 4 divided by 1 minus delta?
Oh. Okay. So I'm trying to find what this is. Okay. So this is a series, the sum of deltas powered by increasing numbers. So how do I figure out what this thing is? Well, I cannot simply calculate this because it has like an infinite sum. Okay, so what I do is I play a trick. Let's call this A. So I'm trying to find A. Okay, then I'm going to write this left-hand side as 1 plus into the parentheses of delta, 1 plus delta squared. Does it make sense?
Yeah.
So the left-hand sides are the same. And you can see that the expression in parentheses is A. So it goes to infinity, right? So 1 plus delta A is equal to A. If you solve this for A, 1 is equal to this, and A is equal to 1 divided by 1 minus delta. And what was A? Okay, we don't see. So from here to here, I subtracted delta A from each side, and then I took into a parentheses of A.
Wait, how'd you get those? How'd you get from 1 to 1?
Here to here?
Yeah.
Okay, so subtract delta A from each side,
Yeah.
and then take this into a parentheses of 1.
Factor it
on
out.
A.
Okay.
Okay. So A is equal to 1 divided by 1 minus delta. Now, what was A? A was the infinite sum of these deltas. So now I can go back and substitute it into my payoff function.
Okay.
Okay? So if you stick with choosing high effort all the time, your payoff is going to be 20. What if you cheat? So the firm is still using the same strategy, but instead of choosing high effort, you choose low effort. So let's look at the payoff matrix. The firm in the first period is choosing high wage, and you are supposed to play high effort, but instead you play low effort.
How come to start anyway, they're playing high wage if the Nash equilibrium is low wage?
Because this is not a one period game anymore.
But when you start at the equilibrium and then go to the next one on the next period,
What do you mean?
like I thought
So
you're
right now, when you repeat the game multiple times, you cannot use the stage game Nash equilibrium anymore, because it's not the equilibrium. The game is different now.
But I thought since like for the first period, since that's like just the one time you use the equilibrium and then you can't anymore. I thought that's how it was, like on one of the problems you were doing on the video.
No. It's related to the strategy that you are choosing. Here, what are we trying to do? It's a prisoner's dilemma. If you play this game only once, you end up getting a bad outcome, 2-2. We are trying to show that if you repeat this game multiple times, we can get a better equilibrium.
Yeah, so how come, but if you did it once, so that would be the first period, how come like it's not the first one plus and then the next ones?
It is.
But it's not the 2, it's the 4. Like,
but remember, okay, look at the strategy that the firm is using. And think about the purpose of the firm. The firm is going to design this strategy, and it's designing this strategy to be able to get WHEH as the equilibrium. WHEH is not the equilibrium in the one period game. But by repeating this game, the firm is trying to reach this outcome.
Is that because that's just what you put for the problem, or like that's just like how it should be?
Well, it depends on what your purpose is. Here, the purpose of repeating this game is to be able to reach a better outcome. So the better outcome, I look at this, the better outcome is 4-4.
For everyone.
Yeah, for everyone. Okay, so here I'm trying to break this dilemma by repeating the game. And in order to break it, the firm says, okay, let's start playing WHEH, which is actually not the equilibrium in the 1 period game. But if I incorporate a, how do you say, if I incorporate a punishment phase, then I may end up getting 4-4 WHEH as an equilibrium. Okay, so let me tell you what this punishment stuff is. So the firm is starting with WH, and the worker was supposed to play EH, but he cheats and play EL. So for the first period, the worker benefits from this because instead of getting 4, he gets 6. Okay, but the punishment is the following. From the second period on, there is no way for the worker to get 4 anymore.
Because they're going to choose WL.
Because they are going to choose, because the firm is going to choose WL. And as a best response, the worker is going to choose EL. So I have 6 in the first period, but then I have a bunch of 2, 2, 2, 2, 2, 2, 2 until eternity. And of course, I need to discount these 2s because they belong to future. Does it make sense?
Yeah. So how come that's not what we did? How come instead we just did the 4 plus 4 plus 4?
We are comparing 2 different things. 4 plus 4 plus 4 plus 4 is when you stick with the strategy, so you are cooperating forever. Here, we are checking if it makes sense for the worker to cooperate. So we are saying, what if he cheats?
Oh, okay.
And then we are going to compare this payoff with the 20 that we found before. If this number is bigger than 20, then the worker is going to cheat. So you cannot reach WHEH as an equilibrium. If this number is less than 20, then it's better for the worker to keep playing EH as a response to WH.
Okay, I got it.
So let's solve this. Again, I need to use the same trick that I used. I have 6 plus 2 delta plus blah, 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 blah. So I'm going to take this whole thing into a parenthesis of 2 delta, which gives me the nice expression of 1 divided by 1 minus delta. Delta is, what was delta? 0.8. So I have 6 plus 1.6 divided by 1.2, 14.
Okay.
All right, so here in this part, we checked the best response of the worker. So here we show that if the firm keeps playing WH, the worker is going to cooperate and he's going to play EH. The next step is, should the firm play WH? I guess that's the next part. Let's see. Okay, I'm looking at part C. Oh no. Okay. So in part C, in part D, we are going to check the employer's the employer strategy. So in part C, we are considering changing WH. What is the smallest level of WH that the firm can use to get high effort from the worker in the infinitely repeated game. So since WH is changing, my payoff matrix is going to change. Right? So right now, so WL, EL, these numbers are the same because WL is not changing. But WH is changing. So if first number belongs to the firm, the second number belongs to the worker. So if the firm pays WH here, and the worker shows low effort, the outcome is going to be 4 low. So 4 minus WH is going to be the the firm's payoff. And here the outcome is going to be high. So this is 10 minus WH for the firm. And for the worker is paid WH, but he shows low effort, which is here 0. So this is WH minus 0, and here WH minus high effort 2. Okay, now I'm going to repeat the exact same calculations. So I want WHEH to be in equilibrium. This is for the repeated game, right? Let me check.
Yeah.
Yes. So if the worker chooses EH, he's gonna get WH minus 2 forever. So an infinite sum of WH minus 2 is gonna be WH minus 2 divided by 1 minus delta. Right? So this was like 4 divided by 1 minus delta from the previous part. And if he chooses to cheat, he's gonna get WH for 1 period, and he's gonna get 2 for all other periods. Okay, so this was one minus delta. Delta is 0.8. So 5 times WH minus 2, greater or equal, or greater, it doesn't matter, WH plus 2 delta, 1.6, divided by 0.2. So this is 8. 5 WH minus 10 greater than WH plus 8. 4 WH greater than 18. WH is greater than 4.5. So as long as the firm chooses a wage level higher than, greater or equal, it doesn't matter, greater or equal than 4.5, then it can make the worker choose the high effort forever.
I'm sorry, how did you get the 5 in front of the
This is WH minus 2 divided by 0.2. So dividing by 0.2 is the same as multiplying by 5.
Okay, thank you.
Okay, guys, give me a second. I need to free my puppy because she's crying a lot. Okay, I'm back.
I have a question about the email you sent pertaining to grading.
Yes.
So you said you were gonna make the average in the class adjust. Does that mean you're gonna alter like the grading scale, or how does that work?
Yeah, I'm gonna add points at the end of the semester. So I'm gonna calculate your overall grade, and then I'm gonna adjust the grading scale.
Okay, and is
So
that
the average is something around B plus.
okay? And I just generally last week especially, I felt like there was a lot of content of the most complicated content we've
Yeah,
had.
yeah, I know. Well,
And-
actually, last week was kind of a one and a half week of content.
Yeah, so I think that was part of it, but I'm just feeling really anxious about this exam in particular because I don't feel like I'm as up to last week's content in particular. And I like classroom setting, you're able to pace it more so with the students and their understanding than in a tape setting, and we can't really like control that because we're online.
I mean, online teaching, especially a class this hard, I mean, as hard as game theory, is very challenging. I mean, it's challenging for you, it's challenging for me. When I see you, like in person, it's way easier to explain the concepts. I mean, right now, I mean, I see you guys and I'm able to explain you like in my office hours, but there are like many people who don't show up in my office hour. I mean, I'm not worried about you guys. You will be fine.
Okay.
I'm more worried about the people who don't show up.
Okay.
Yeah. Yeah, and about last week's and this week's content, there is not a unique way of solving these questions. So I'm not sure if you saw the pattern, but there are only 3 things that we are checking. So we are checking in every question, we are checking incentive compatibility, we are checking the participation constraint. So these are for the like high information group, having high information player. And for the firm or for the low information player, we check the profit maximization, I mean profit payoff or whatever, utility maximization. So we are basically doing these 3 things over and over and over with different examples. So when you look at it like this, it's actually very simple because we are only checking 3 different things and that's it. But it's also very complicated because for each question type, for each example, you need to alter these stuff. Like you need to find clever ways to solve the profit maximization problem, for instance. You need to be very careful with the probabilities when you form the incentive compatibility constraint. So, I mean, it's easy, but at the same time, it's hard. That's why it's very important to see lots of questions. And you are lucky because in our book for mechanism design and for imperfect information, there are lots of questions. There are lots of solved questions, solved example, and also unsolved examples.
Okay, so does this structure also apply to those really large extensive form games that were in the videos last week? Because I know we were doing a lot of profit maximizing for that, or is this just for like the insurance and the lemons?
Oh, this is only this is not for the this is not for the extensive form game trees.
Those
Okay,
suck.
Yeah.
okay. Could you
But of
do,
course, I mean,
sorry.
it's always possible to write an adverse selection problem or a moral hazard problem using an extensive form game tree as well. But I
Okay.
mean, you don't have to. What, for instance, when you check incentive compatibility constraint, I mean, this number should be greater or equal than this number. What you are doing is simply in an extensive form game, you are eliminating one of the branches. So actually when you check these three constraints, I mean, without drawing the extensive form game, you are actually working on an extensive form game, right? Because incentive compatibility, I mean, if this is, I don't know, high type, high effort, low effort, then you are actually checking the, I don't know, the effort of the person, right? And you are eliminating based on these incentive compatibility constraints. Okay, of course, the payoffs are not like this. The payoffs depend on, I don't know, of the variable that the other player is choosing. So it is like, I don't know, this depends on WH, WL stuff too.
Can you finish the part D of that
Oh
problem?
yeah, sure. Okay, so we are still solving question 1. Was this question 1? Question 1, part D. So now I'm ignoring part C, and I'm trying to figure out if Grim Trigger is a subgame perfect-Nash equilibrium of the game. I have already checked the worker, right? So if the firm plays WH, the worker is going to comply by choosing the high effort. Okay. Now I need to check for the company. Okay, so I need to make sure that playing WH, given that the worker is playing Grim Trigger as well, is going to give us a higher sum of discounted payoffs than cheating and choosing WL. Okay, so if the employer chooses WH, when you go back and check the payoff matrix, you will see that he's going to get 4. Right? So by complying, he's getting 4 forever. So 4 divided by 1 minus delta. Since delta is equal to 0.8, this is equal to, what is this?
20.
8? No, 20. Okay, so I'm gonna check the payoff of the employer if he cheats. So if he cheats, while the worker is following Grim Trigger, in the first period he's gonna get 8. But in the remaining periods, the worker is going to choose EL as well. So the punishment phase is starting and they are both getting 2 forever. So 8 in the first period, 2 forever. 8 in the first period, 2 forever. This puppy is gonna kill me. Okay, let's solve this. I'm taking this whole thing into a parentheses of 2 delta I'm checking if this is true. 8 plus 2 delta divided by 1 minus delta. Delta was 0.8, 0.8, 1.6 divided by 0.2, 16. So yes. So the employer is going to choose WH as soon as, as long as the worker is choosing EH, and the worker is choosing EH as long as the employer is choosing WH. So this is both a Nash equilibrium and a subgame perfect Nash equilibrium. It's subgame perfect Nash equilibrium because we check deviations. There exists no profitable deviation.
For the exam, are we gonna, since it's not like on honor lock, are we emailing you our exams again, or are we gonna submit them on Canvas?
You are going to submit it on Canvas. So the only thing that will change for you, it's going to be like submitting a homework. You will download the file, and when you are done, you will upload it back.
So is there gonna be like a time limit also?
Yes, yes. Well, this time I'm going to give you guys more time. You will have 2 hours in total. 2 hours to work on the exam, and like another 15 minutes, 20 minutes to submit the file.
So it won't be available till 11?
Yes. So from 11 to 1, and then you will have some more time to submit.
Professor, I had a quick question on that final part.
Yes.
Of the, I was looking at the answer key, and it says that the employer is better off following Grimm, but
Yes.
and so Grimm is the subgame perfect Nash equilibrium, but since that paying the higher wage and not cheating for both is better off, wouldn't it be like not cheating being like the subgame perfect? Like, why would Grimm be the subgame perfect?
Okay.
Because isn't Grimm both of them cheating?
Okay. Remember, you are talking about 2 different games. Not cheating belongs to, these are strategies for one-shot game. Grimm is the strategy in the infinitely played game. Because remember, a strategy must tell you what to do at every point when you make a decision. So that's why you cannot say that. So in the infinitely repeated game, you cannot say that WHEH is an equilibrium. Because in the infinitely repeated game, WH is not, WH is not a strategy. If you are asking this, for example, why always play WH and always play EH is not a subgame perfect Nash equilibrium. Is this what you are asking?
Oh no, I was just getting confused about Grimm, what exactly Grimm means. But I understand that Grimm refers to the idea that if the game is played infinitely, then they would both not cheat. Okay.
And it tells you what to do at every decision node that you may reach. For example, Grimm tells you the following. In the first period, you play, the employer plays high wage. In the second period, if the worker played EH, you play WH again. But if the player played EL, then you are going to switch to WL. And then in the third period, if you have switched to the WL in the second period, then you will keep playing WL. So in other words, Grimm is a very compact way of saying that these are the actions at each period.
Oh, okay. Okay. And since they both know the payoffs, that that cheating would get them less, they're both in Grim Grim. They're both, of course, going to always play WH infinitely. Then.
Not that because they know the payoff. Because lambda is high enough. I mean, delta is high enough.
Oh yeah. Okay. Okay. Yeah. Okay.
Right? If delta
Yeah.
is very small, it means that you don't value future that much. And the future is the punishment phase. So if you
Okay.
don't value future, you don't value punishment, so you can cheat.
Okay. So since the discount or the lambda is closer to 1, okay.
Yes, yes.
So for Grim, once you switch, you can't go back.
Yes, you cannot.
But then for the other one, you can.
For tit for tat, yeah. Then you simply follow what the other person has played the previous period. Okay, other questions?
Can you do an example of an extensive form game that uses like profit maximization? Because I know a couple of them get really long and complicated. Yeah.
Okay, I don't have an example now. Have you checked the
Okay.
book?
No, I have it here though.
Okay.
So I guess for these problems, you gave us kind of the steps we have to go through, the different compatibility constraints and the utility maximization. Is there a strategy like that that you can just outline for doing those types of extensive form problems?
Are you asking me the problems that we are solving drawing extensive form games, or like when I give you an extensive form game, I'm asking you to find the equilibrium? Is that what you are asking? Or are you asking me like we construct the constraints for the players and then like we take derivative, for example, to maximize the profit of the firm?
I'm talking about like the cheap talk examples where you draw the extensive form and then try to find the Nash equilibrium, but there's points where it's like simultaneous and when it's not. And
I don't have an example right now.
okay.
Okay. So why don't I find an example and solve it and then send you guys? I mean, I'm gonna post it on Canvas.
Okay. Sounds good.
Hi, Dr. Ganai. I had a question about the worksheet, so number 3.
Okay, did you find more mistakes?
No, I didn't. But I was just curious, and I was hoping that you could explain. So in number 6 and 7 of the tying and bundling example.
Okay, let me, worksheet 7, right?
Yes.
Okay, we are in tying and bundling example on worksheet 7. Yes, and your question is?
So with number 6, why can you only charge $100 for the bundle? So it was saying, yes, I understand that A wouldn't have any consumer surplus, so they would prefer to buy $80. But in my head, that doesn't really make much sense since if they buy the $80 package, they don't get the extra value from the Excel.
Okay, give me a second. I'm gonna lock my dog again.
Oh.
Go spit. Okay, we don't bark. We don't bark, okay? Okay, she's quiet now. Okay, can you repeat your question?
Of course. So on number 6, so in the answers it says that the bundle you should only charge $100, and I was confused on why it wouldn't be $120. So I understand that A doesn't get any consumer surplus for the bundle if you
Yes.
charge $120, and so they would want to go with 80. But that's where I'm a little bit confused, because with the $80 they don't get the extra value of having Excel as well.
Are you talking about A or C?
This is for A, sorry. I understand C. I understand why C would only get the $80.
Okay, I need to read the question. Sell to each consumer. Okay, you are asking me why the price is not 100, but it's 120?
Why not? No, the price is 100 in the answers. So I was wondering why it's not.
Wait, aren't you talking about part 6?
Is it part 6? Yeah. Oh, no. Okay, sorry.
Okay,
guess it
because I
must
was
be
looking at part
7.
6.
I skipped one. I think I just wrote 6 twice, so it should be number 7. Sorry.
7, okay. Okay, so what prices for the 2 products and the bundle will the firm set to maximize its profit? Okay, so first of all, we need to decide which consumers we target with each product.
Yes.
So when I look at the payoffs, I see that,
Well, you should charge $80 for the Word stuff, because that's C values it at 80, and they don't care about the bundle at all.
yes, and for the bundle, so what I can do is, if you look A and B, you can charge $130, for example, for the bundle.
Yeah.
And sell only 1 copy, right? Because the willingness to pay of A is only 120. But in that case, you will sell only 1 copy. So your profit is going to be 130 plus whatever you make from C.
Yeah.
And the alternative is to charge $120, but then you are going to sell 2 copies. So 120 plus 120, instead of 130, you are getting 240.
Yeah. So I get that. Okay. And you want to charge $80 for the C package.
So that's why, I want C to purchase Word stuff.
Yes.
And I want A and B to purchase the bundle.
Yes. So why is 100 the one that maximizes the price? So I understand you get, if A were to buy the 80 or the bundle for C, they would get $20 in consumer surplus, essentially. But the thing is that they value the, wait.
So we are between 2 prices, right? 100 or 120?
I think I actually get this part, because I'm trying to understand why if the price were 120 for the bundle, why would A still go with the C bundle? So why would A purchase C rather than, or just the Word stuff at $80 rather than the bundle at 120? And I think what it might be is that you've got, so if word stuff is $80, then if A were to
Okay,
get the
wait.
bundle, they would
Wait.
with
So
40.
if word stuff is $80, if A
Yes.
purchases word stuff, he's gonna get a net payoff of 20,
Yes.
right? And if you charge the bundle, anything greater than 100, A is going to purchase only word stuff,
Yeah.
right? So you
No, I
cannot,
get this now.
you cannot make the price level greater than 100.
Yeah.
So
That makes sense now. Actually, quick other question. So in the answers, you say that the final expected profit is $28,000, but from earlier you were saying that you could charge $130 for the bundle, and then you could have $80 for just the word stuff. And if that happens, you'd actually get an expected profit of $29,000, because you'd have A and C would both buy the $80 package to get you $16,000 of profit, and then B would buy the $130 bundle and would get so you get $13,000, which would give you a net of $29,000. If I did that right.
yeah, if that's right, then I need to change the answer key.
Okay.
So so let's see. If you charge, when you charge $80 and you charge 130. Okay. So if you charge $130 for the bundle, yeah, you are right. You are right. I'll change that. So the optimal bundle is you are gonna sell the bundle only to B, charging the highest price possible. And you will sell A and B only word stuff.
Yeah.
Yeah.
Okay. Thank you.
Cool. Thanks.
That was helpful.
Okay, guys, questions?
Can you do number 2 on the practice exam also?
Let me see. Practice exam. Okay, so in this problem, we are still looking at the same numbers in question as in question 1, but now we have, what is this? Okay, so we are only playing this game once. And okay, so we have 2 different possibilities. If the worker, the manager chooses EL, then the output is going to be YL for sure. But if the worker chooses high effort, then we will have YH with a probability of 50% and YL with a probability of 50%. The values that were given before still holds, YH, YL, EH, and EL. And this time the worker, the manager, the worker has an outside option, U0, which is equal to 2. So this outside option is important when we construct the participation constraint. So we need to make sure that the worker gets at least 3 units of payoff. Okay, so part A. If the firm could observe the effort directly, so he can directly say that your effort is L, your effort is H. If he can do that, then he can write a contract simply based on the effort level. So he can offer WH to people who shows high effort, and WL to people who shows low effort. Okay, so what wages should he pick up? Well, I want to make sure that the people are willing to work for me, right? So when I pay WH to a high effort person, he has a cost of 2. So this is the net kind of utility of the person with high effort. I want to make sure that this is greater or equal than what the person could get outside. So this is the participation constraint of the high effort worker. Similarly, I want the low effort worker is gonna show effort level 0, so WL minus 0, to be greater or equal than 3. So this is the participation constraint of L, okay? And remember that the firm wants to pay lowest wage possible, right? Because that's how he maximizes his profit. Since I don't have any other constraints, WH is going to be simplified and WL is going to be equal to 3. Here, I don't need to worry about incentive compatibility constraints because no one can lie to me or can fake, okay? So I know who is EH, who is EL. That's why only participation constraints matter.
How do you know that?
I'm sorry?
How do you know that no one can lie?
It's given in the question. So if the firm could observe effort directly and perfectly,
So if you couldn't, then how would you adjust it?
then I need to have incentive compatibility constraint such that the high type worker, I mean high effort worker, high effort worker is going to be better. Wait.
They wouldn't be better off not working?
Yes. No. That would be participation constraint. So I would adjust it by saying that if you are high type, you don't want to look like low type, or if you are low type, you don't want to look like high type.
Is that the one where where like in one of the videos, it was just a number, like a single number?
I mean, this is what we check pretty much in every asymmetric information question. So for example, in Lemon's example, we had that. I mean, in Cheap Talk examples, we had that.
Wouldn't it be the WH minus 2 is greater than or equal to WL?
Yes. Okay, so here I know who is showing high effort, who is showing low effort, okay? Well, the thing is, this question, as I said before, is different than other questions where nature was choosing the type. Here, the person is choosing his own type. So if I want, I can show high effort. If I want, I can show low effort. Okay, that's why calculating the profit is kind of different here. So
And where do you
remember,
use the probabilities?
what?
When do you use the probabilities?
I use the probabilities if there is something unknown. So in this question, the probabilities are useful because even if the worker shows high effort, there is still a possibility of getting low output. You know, YL is either, output is either YL or YH with equal probability. And remember, I know who is low effort, who is high effort, okay? So if the worker showed low effort, then I will definitely get an output of YL, right? That's for sure. And I'm paying the worker WL. So 4 minus 3, my profit is simply equal to 1. This is not an expected profit. This is a sure profit because I know that when I have a low effort worker, I will definitely get an output level of 4. Okay? The expectations, the expected profit stuff is when I have a high worker. When I have a high worker with 50% probability, I'm gonna have high output. And remember, this is a high effort worker, so I'm paying the worker WH. But with a 50% probability, I'm gonna get low output. But I'm still paying the worker WH. Okay, so that's why this profit is the expected payoff, expected profit. It's not sure. WH is 10, 10 minus 5. The YL is 4, 4 minus 5. So this is 2.5 minus 0.5. The expected profit from having a high effort worker is equal to 2. Does this make sense?
Yeah.
Okay, so in this case, I know who is EH, who is EL. In the next case, I don't know. And I'm offering 3 different contracts. So what is contract 1? Contract 1 has just a fixed wage. So I'm paying W to everybody. Okay. Contract 2 is I pay, where is this? A base wage of W0. So this is for sure. So I'm paying W0 to everybody. And I pay B if output turns out to be YH. Okay. Does this make sense?
Mm-hmm.
So these are the 2 options. The third contract is simply shows the outside option. So the worker is not working for the guy. Okay, so first of all, we are going to look at contract 1. What wage will the firm set? So I'm looking for W, and I'm looking for the expected profit. And remember that I don't know who is L type, who is H type. So I don't know whether the worker is going to show high effort or low effort. Okay. All right. Now, Let's see. Let's talk about the H-type person. Remember that if the person shows high effort, the profit of the firm is going to be an expected profit because there's a probability of high output and there's a probability of low output. And I'm offering W to high type. Okay, so when you simplify this, so this first part is if the output turns out to be high. The second part is if the output turns out to be low. When you simplify this, you get 0.5 YH plus 0.5 YL minus W, okay? And I already know YH and YL. YH was 10, YL was 4. So this is 7 minus W. If the person shows high effort. Okay, and if I'm faced with a low effort worker, then the output is gonna be YL for sure, and I'm paying W anyway. So I'm gonna get 4 minus W. Now, these are the possible scenarios. My worker may show high effort and I expect to get this, or my worker shows low effort and I get this. What do you think the worker is gonna do? Show high effort or low effort?
High effort?
Okay. If I show high effort, how much I'm paid? I'm paid W. If I show low effort, how much I'm paid? Again, W, right? And there's a cost of showing high effort. So if I'm paid exactly the same, why would I show high effort? Remember, high effort costs $2. So if the firm offers exactly the same wage to low effort and high effort, let's say types, then people will always choose low effort. Okay, because there is no benefit, there is no gain in showing high effort. Okay, so this will never happen because you will never see a high effort person. So your profit is 4 minus W.
Why can't you just do 7 minus W is greater than 2?
Where is 2 coming from?
The cost of doing high effort.
This is the profit of the firm.
Oh, okay.
Right? So what I'm doing is this. If you check for the worker, with high effort, the worker is gonna get W minus 2. He's paid W and the cost of high effort is 2. If he chooses low effort, it's simply W minus 0. So of course he's going to choose low effort. Okay, and when the worker chooses low effort, the firm gets the profit from low effort.
Okay.
Now I'm trying to choose W to maximize my profit. What is the lowest level of W I can offer? Because remember, if W is small, my profit is big. What is the lowest W?
3.
3, because remember the workers have an outside option. They can easily work somewhere else and get 3. Right? This is U0. So I need to offer at least $3 so that the worker chooses to work for me. So this is the participation constraint. Okay? So the lowest wage the firm can choose is $3. And as a result, his profit is going to be 1. And he will always see low effort. Or the worker will always choose low effort. Does this make sense?
And so this is all for just contract 1?
Yes. So the optimal contract 1 is to offer 3 to everybody and get a profit of 1. The worker will definitely show low effort, and as a result, you will definitely get low output, YL. Okay? So keep this profit equals 1 somewhere in your head, because we are going to use this later. Now I'm looking at contract 2. In contract 2, I'm offering W0. So this is the base wage rate. And I'm also offering B if the output turns out to be YH. Okay, so remember the probability of YH. If I see YH, what do I know? If output turns out to be high, I know that the worker chose high effort, right? Because with low effort, the probability of, so if the worker chooses low effort, I will definitely get YL. So if you are a low effort person, you will be paid only W0. If you are a high effort person, with 50% probability, the output is going to be YH, so you will be paid W0 plus bonus. With 50% probability, output is going to be YL, and you will be paid only W0. So this time, I'm going to have expectations for the worker as well, because with 50% probability, the high effort worker is going to be paid W0 plus B, and with 50% probability, he will be paid only W0. Okay. So now, how do I construct this? Well, the worker chooses low effort. So if worker chooses L, we said that his wage is going to be W0 for sure. If the worker chooses high effort, then with 50% probability, it's going to be W0 because the output is low. With 50% probability, it's W0 plus bonus because the output is high. Okay, so this is W0 plus 0.5 B. Okay, so this is the payoff from high effort, and this is the payoff from low effort. Now, the person is willing to show high effort if and only if this number, if and only if this number is bigger than this number. Okay, now, what is the expected utility from high effort? You have the payment, W0 plus 0.5B, but you chose high effort, and high effort costs you. EH is 2, right? So it costs you 2. Okay? And if this value, the expected utility from high effort, is greater or equal than the expected utility from low effort, which is W0 minus EL, which is 0, then you are going to choose high effort. So here, W0s just cancel out. B greater or equal than 4. So if you keep bonus greater or equal than 4, then the worker is going to choose high effort. Okay? And remember, you are the firm, you are trying to maximize your profit, so you will choose the lowest B possible. So this will be binding. So B is going to be equal to 4. Okay, does make sense? This is from the perspective of the worker. So here, if the firm wants to use high effort worker, because remember here, the worker is choosing to exert high effort. So if the firm wants the worker to choose high effort, he needs to choose B equals 4.
How do you know what the wage is for the high, for them?
I don't know.
Then so can't you not calculate the profit?
That's what we are trying to find out. Okay, ask me again.
No, I was just going to say, how can you calculate the profit then if you don't have the wage?
You will see in a second. Everything is gonna be in terms of W's and B's. Okay, so let's calculate. So the profit, if I use only L worker. Okay, this is the easy one. If I have an L worker, definitely I'm gonna have low output, and I only pay W0 to L workers. So the profit, if I use only L workers, is 4 minus W0. Okay, I don't know W0. I'm trying to find W0. What if I use H worker? If I use H workers with 50% probability, my output is going to be high, but I'm going to pay W0 and B to my H worker. With 50% probability, my output is going to be low, and in this case, I will only pay W0 to my worker. YH is 10, YL is 4. I have already calculated B to be equal to 4. So here, 0.56 minus W0 plus 0.54 minus W0. This is 5 minus W0. Right? 0.5 times 6, 3. 0.5 times 4, 2. 3 plus 2, 5. Minus 0.5 W0. Minus 0.5 W0. minus W0. Now I'm ready to make the calculation. Do I want an L worker or do I want an H worker? What do you want? An H worker or an L worker? What? You want an H worker, right?
Yeah.
Because your expected profit from H worker is higher than the expected profit from having a low worker. So we are safe. I want to have an H worker, and I can get the H worker if I set B is equal to 4. Okay, so we found B. What about W0? How am I going to find W0? Remember that now I have H workers, right? The H workers will get a payoff of W0 plus B with a probability 50% because output is high with a 50% probability. And they will be paid only W0 if the output is low. And they exert high effort. So I have EH here. So this is their utility from H, right? I want this person to work for me, which means that I don't want this guy to go to his outside option. So this has to be greater than 3. Does this make sense? B is 4, EH is 2. So here I had W0 plus 2 minus 2 greater or equal to 3, WZ0 greater or equal to 3. Since I'm a profit maximizer, I'm going to choose the lowest wage possible, which is in this case 3. Now, what is contract 2? Contract 2 is the following. I'm offering you a base wage of $3. If output turns out to be high, you will get a bonus of $4. As a result of this contract, the worker is going to show high effort, and your output is going to be high with a 50% probability and low with 50% probability. Okay, does this make sense? I know it's long. It's long, but we keep checking 3 different things. We keep checking profit maximization problem, we keep checking incentive compatibility, and the participation constraint.
So what's the expected profit for the entire contract for 2?
Oh, sure. So what type of worker do you have? Do you have low type worker or high type worker?
I guess high.
High type, right? And when you have high type worker, the output is going to be YH with a probability 0.5. So with 50% probability, you will have YH, but you pay W0 and B. And with a probability 50%, your output is going to be YL. And in this case, you will only pay W0. So if you plug all numbers here, you get 1.5 plus 0.5 equals 2. You can see that. Remember the thing that I told you to keep in your head? Profit is equal to 1. So when the firm was offering the same contract to everybody, his expected profit was 1. Now, when you offer a contract with a bonus, your expected profit is 2. Okay, so contract 2 is better than a simple flat wage. And the reason is pretty simple, because when you offer a bonus, you encourage your worker to show high effort. And in that case, your output increases. Okay. Any questions? Any questions? Questions? Okay, we have 9 people.
For the multiple choice on
Yes.
the practice exam for number 3,
Uh-huh.
how come only C is an adverse selection?
Okay, let's see. Let's see. Okay, so both adverse selection and moral hazard, they are due to asymmetric information, okay? But one of them happens before you make your decision. The other one happens after you make your decision. So for example, if you are purchasing a health insurance because you have like super health problems, then this is an adverse selection problem. Because the problem arises before you make your decision. So you were already high risk for the insurance company before you made your decision. But you are healthy, you buy a health insurance, and after you make the purchase, you changed your type. So for example, now you are undertaking risky activities because you know that you are covered with a health insurance.
So that's
This is
not
moral hazard.
adverse?
I'm sorry?
So that's not adverse selection?
Yes, that's a moral hazard problem. That's why A and B are moral hazard problems. Because they make the purchase and then the type of the person changes. So in A, the individual start using more medical services after he purchased the insurance plan. In B, the person starts bungee jumping after purchasing the health insurance. In C, well, there are risky people and less risky people, but the bank cannot see who is risky, who is less risky. So high risk people may come to you and may be interested in your in loans. That's adverse selection.
Okay.
And D is a simple imperfect information problem.
How is like C also not just imperfect information?
It is. But in addition to imperfect information problem, not only imperfect information, it's also an asymmetric information problem. But D does not result in an adverse selection problem. So in adverse selection problem, the idea is this: you are selling something. So for example, if you are selling health insurance, you want low risk people to buy your health insurance, right? But the
Yeah.
people who purchase health insurance are actually the people who need health insurance. So there's an adverse selection here. I mean, if you know that you are not gonna be in an accident, why would you buy, I don't know, car insurance? That's the same idea. You know, people who think that they are gonna use the insurance are more interested in purchasing the insurance. That's why it's called an adverse selection. Instead of choosing the low risk group, high risk group is interested in your product. I hope it makes sense.
Yeah, I think so.
Okay. All right, guys. Other questions? So tomorrow I'm gonna have more office hours. Meanwhile, I want you guys to go over the last worksheet and also the practice questions so that you can ask your questions tomorrow. All right?
Thank you.
Okay, thank you. If you don't have any questions, so I'm finishing the meeting now. Oh, I see a puppy. Oh, hello.
He really liked your dog barking.
Yeah.
Now. Hey, puppy. Look, I have a friend for you.
Oh, yours are so cute.
Your dog is so cool. I mean, he doesn't pay attention at all. He's like, I'm a cool dog.
Kind of.
Hey,
Just-
Reed. I see another puppy. Hello. Okay, guys. I'll see you later.
Bye.
Bye.